In section 2.8, we are going to have a little pause on our discussion of functions. Section 2.8, we're going to look at the distance formula, the midpoint formula, and the equations of circles. So we are going to find the distance between 2 points in the coordinate plane. We're going to find the midpoint of a line segment that connects 2 points in the coordinate plane. We're going to look at the standard form of a circle's equation, and from that standard form, we can determine a circle's center in the coordinate plane, and we can determine its radius. We're then going to last look at the general form of the equation of a line. And it's not particularly helpful to look at general form of any equation. So we're going to take that general form and we're going to convert it to standard form. Because once the equation of the circle is in standard form, we can find the center and we can find the radius. So first, the distance formula. The distance formula between 2 points on the coordinate plane is found by taking the square root of the difference of their x-coordinates squared plus the difference in their y-coordinates squared. This formula is derived from the Pythagorean theorem. As you recall, if I have a right triangle, then the hypotenuse, which is C, can be found by squaring the two legs of the right triangle and adding those two things together. So C is the square root of A squared plus B squared. And if these 2 points are actually, we can give them coordinates in the coordinate plane. If we give them coordinates, then the distance or the length of the side of the two sides of my right triangle are going to be the distance in the horizontal direction would be x2 minus x1. The distance in the y direction would be y2 minus y1. We square those two legs, we add them together, and we take the square root, and that gives us the distance formula. Now, the only issue with using the distance formula that I know of is sign errors. It's actually fairly forgiving because you're going to take the difference in the x's and the difference in the y's and then square them, which makes them positive. So it's a little forgiving in that regard, but you do have to be careful to make sure that you are subtracting the x coordinates and you're subtracting the y coordinates. Oh, PowerPoint. All right, so let's find the distance between these 2 points. And you can give them a quick label just to help you in substituting into your formula. The first point, make that x1, y1. And the second point, make that x2, y2. And that'll help you a little bit in the substitution. So the distance between the 2 points on the coordinate plane would be the difference in the x coordinates squared plus the difference in the y coordinates squared. And we're going to take the square root of that. And now we're going to make these substitutions. We have 2 minus a minus 1, that is squared, plus 3 minus a minus 3, and we're going to square that difference. So we're going to get the square root of 2 minus a minus 1 is 3. 3 minus a minus 3 is 6. 3 squared plus 6 squared is 9 plus 36, which is the square root of 45. And we are going to be expected to simplify that radical. 45 can be written as 9 times 5. And from the laws of exponents, The square root of a product can be written as the product of the square roots. And the square root of 9 is 3. So the difference between those 2 points on the coordinate plane is 3 times the square root of 5. And if you wanted to, you could take your calculator out and you could find a decimal approximation to this. Take 3 times the square root of 5, and that's approximately, and I'm going to use the squiggly equals to denote that's approximately 6.71. Okay, it's not a difficult formula to use. Just be really careful that you are subtracting the coordinates, so be careful with your signs. All right, let's find the distance between these 2 points. So again, I'm just going to label my 2 points, x1, y1. It just helps me substitute into my formula. So the distance between 2 points on the coordinate plane is the square root of the differences in their x-coordinates squared plus the difference in their y-coordinates squared. So the distance is going to be x sub 2 is minus 6 minus 4, and we're going to square that, plus the difference in the y-coordinates, which is 3 minus a minus 1, and we're going to square that. So that is going to be the square root of negative 10 squared plus 4 squared. And whenever we square a real number, we get a positive number. So negative 10 squared would be 100 plus 16. So the distance between these 2 points on the coordinate plane is the square root of 116. And I'm going to look at that number and I'm going to try to see if I can simplify that radical. Does 116 have a factor that's a perfect square? And the answer is yes. 116 is actually 4 times 29. So from the law of exponents, the square root of a product is the product of their square roots. So that is 2 square root 29. And that is the exact distance between those 2 points on the coordinate plane. Again, if we want to find a decimal approximation, we can go to our calculators, and this is approximately 10.77. So exactly, it's 2 square root 29. Approximately, it's 10.77. All right, the next formula we are going to look at is the midpoint formula. And this is actually quite an easy formula to use. So if I have 2 points on the coordinate plane and I connect those 2 points by a line segment, then right in the middle of that line segment, its midpoint is this formula here. So you're going to be finding the average of the x-coordinates. So you're just going to add the x-coordinates together and divide by 2. That is an average. And you're going to add the y-coordinates together and divide that by 2. That would be the average of the y-coordinates. So it's fairly simple formula to use. So let's find the midpoint of the line segment that are connecting the points 1, 2, and 7, negative 3. And again, I'm just going to give my points a label. Sorry about that. PowerPoint is vexing me as I'm trying to record here. So call that x1, y1, and maybe x2, y2. And so the midpoint can be found by taking the average, or just adding the x-coordinates and dividing by 2, and the y-coordinates and dividing by 2. And this is an ordered pair on the coordinate plane. It is a point on the coordinate plane, so we are going to put parentheses around it. Again, when do you use parentheses in mathematics? When you're talking about numbers, you're going to use them around an ordered pair to denote that it's an ordered pair, or you're going to use them when you're talking about intervals on the real number line. So if we have an interval between two numbers, we could use parentheses to designate that. All right, so now let's just go ahead and add these two x's together. So I have 1 plus 7 over 2, and the y coordinate of the midpoint, I'm just going to add the two y coordinates together and divide by 2. So that's 8 divided by 2. 2 plus a -3 is -1. And so our ordered pair, which is the midpoint of this line segment, is 4, -1/2. All right, circles. A circle is the set of all points in a plane that are equidistant from a fixed point called its center. The fixed distance from the circle center to any point on the circle is called the radius. So here is an image of a circle in the coordinate plane. We have a center, and we're going to label that center HK. That is just a typical designation that mathematicians use to designate the center of a circle. And a point on the outside of the circle or on its radius, we could label generally XY. So that's just some point anywhere on the outside edge of this circle. So using the Pythagorean theorem, we can actually derive the equation of this circle. So I'm going to draw a vertical line and a horizontal line here. And we're going to now use the Pythagorean theorem to find this equation. So the Pythagorean theorem says that if I take the sum of the squares of the two legs of a right triangle, I get the hypotenuse squared. Well, the triangle I've drawn here, the hypotenuse is the radius of the circle. This horizontal distance, this horizontal leg, that distance, that length is x minus h. So if this point is xy and this point here is hk, then that distance is x minus h. And I can put absolute value bars around it for now, just to ensure that it's positive. But as soon as I square it using the Pythagorean theorem, it doesn't matter if I have absolute values there or not. I just put them there to assure that no matter what difference I take, that result will be positive. And this distance, this vertical distance, the top point, the y-coordinate is k. The bottom point, the y-coordinate is y. I am going to write that as y minus k, however, because that's the form that I want it in. So I will put absolute values around it to make sure that that distance is truly positive. Now, using the Pythagorean theorem says that r squared will be equal to that horizontal length squared, which is the absolute value of x minus h. But as soon as I square it, I can drop the absolute value bars, because when I square a real number, I guarantee that it's positive. And then that vertical distance, that would be the vertical leg of a right triangle, that's going to be y minus k squared. And that is the standard form of the equation of a circle. If I just do a little rewriting using the reflexive law of equals, so just flip things around the equal sign, here is the standard equation for a circle in the coordinate plane. So x minus the x coordinate of its center squared plus y minus the y coordinate of its center squared is equal to r squared. So the standard form of the equation of a circle with center hk and radius r is x minus h squared plus y minus k squared equals r squared. So now if I'm given an equation of a circle in standard form, I can just look at it and determine where its center is, and I can look at it and determine what its radius is. All right, so I have a circle here whose center is 0, -6, and whose radius is 10. Let's write the equation of this circle in standard form. So the center coordinates, the first number there, that is h, that is the x coordinate of the center of this circle. And the second coordinate there, that is k. K is the second coordinate of the center of the circle. And the radius is 10. So now we're going to substitute into our formula. So we have x minus h squared plus y minus k squared is equal to r squared. So we have x minus 0 squared plus y minus a minus 6 squared is equal to 10 squared. So let's do a little bit of simplification here. X minus 0 is x. Whenever I subtract or add 0 to any real number, I just get that number. So x minus 0 squared is x squared. Then I have y minus a minus 6. So that's going to end up being negative. Negative gives me plus. So that is going to be y plus 6 squared, and 10 squared. 10 times 10 is 100. And so there is the standard equation of a circle whose radius is at 0, -6, and whose radius at 0, -6, sorry, getting fumbled, and whose radius is 10, the square root of 100. I can spit it out. All right, so what if you're given the equation in standard form and they ask you to find its center and its radius? All right, let's write the equation again real quick. That'll help us. Okay, so the arrow I had drawn there was to note, what are you subtracting from x? Whatever number you're subtracting from x is the x coordinate of the center of this circle. And since that's x plus 3, you're actually subtracting -3. So that is equivalent to x minus a minus 3. So the center of this circle's x coordinate is -3. Whatever you're subtracting from the y is the y coordinate of the center of this circle. So since I have y minus 1, I'm subtracting 1. That is the y coordinate of the center of this circle. R squared is equal to this constant here. So r squared is equal to 4. And since we're talking about a distance, we're going to take the square root, and that distance will be positive. We don't need a plus or minus. It doesn't make sense for a radius to be negative. So r is equal to the square root of 4, which is 2. So the center of this circle is at -3, 1, and its radius is 2. All right, last but not least, the general form of the equation of a circle, and this is typical for us for any general form of an equation. General form means that we have the algebraic expression on the left-hand side of our equation, and we have 0 on the right-hand side. So this is the typical general form of the equation of a circle, and I know it's a circle because I have an x squared and a y squared there. And the equation that would have both of those, an x squared and a y squared, in this form would be a circle. All right, it's not a particularly helpful form of the equation of a circle because there's not anything I can just look at it and figure out what anything is. I can't just look at it and determine where the center is. I can't just look at it and determine what the radius is. So typically what we do is we take the general form and we make it standard form. So we do a little completing the square to do that. So to be able to determine the center and radius of this circle in the coordinate plane, I do need to put this general form in standard form. And here are the steps that I'm going to use to do that. So the first thing I'm going to do is do a little rewriting. And I'm going to put the two x terms together. And I'm going to put the two y terms together. And then the next thing I'm going to do is I'm going to move that constant to the right-hand side of the equation. So whatever that constant is, I'm going to move it. And I'm going to move it from the left-hand side to the right-hand side, and the minus is going to become plus. And the reason for that is because I'm actually adding 1 to both sides. So when I move the -1 from the left to the right, that -1 becomes +1 because I'm adding it to both sides. Okay, now I'm going to rewrite this, but I'm going to leave a little space behind the x term and the y term. Okay, get my x squared there. So I have x squared plus 4x plus y squared minus 4y is equal to 1. And now I'm going to complete the square on the first two terms on the x and the first two terms in y. And the reason I complete the square, if you recall from chapter 1, when I complete the square on two terms of a trinomial, the first two terms of a trinomial, it becomes a perfect square trinomial. And a perfect square trinomial factors to a binomial squared. So I'm going to force this to be a perfect square trinomial by adding that appropriate constant. And how do you find that appropriate constant? Well, you're going to take the coefficient on your x. You're going to divide that by 2. 4 divided by 2 is 2. And then you're going to square that. So 4 divided by 4 is, 4 divided by 2 is 2. 2 squared is 4. So that's what I'm going to add to these two terms to make that a perfect square trinomial. So I take the 4, I divide it by 2, and then I square that result. And I'm going to add that right there. Now, whatever I add to the left-hand side of the equation, I must also add that to the right-hand side of the equation. We must keep this equation in balance. So the right side and the left side must be balanced. All right, and I'm going to do the same thing to the y, and it turns out that the coefficient on y is also 4. 4 divided by 2 is 2. 2 squared is 4. So we're going to add that there, and we're going to add that there. So on the right-hand side, I'm going to get it 9. And on the left-hand side here, now I have two perfect square trinomials, and it factors to a binomial squared. So this factors to x plus 2 squared. And this number right there, that number right there, is always half of that number right there. So 2 is half of 4. So down here, we're going to get y, and since this is minus, we're going to get a minus here, y minus 2 squared. So now we have the equation of the circle in standard form, and I can determine the center, and I can determine the radius. So whatever I'm subtracting from x, so since that's plus 2, I'm subtracting minus 2. So the coordinate, x coordinate of the center of the circle is negative 2. Since I have y minus 2, I'm subtracting 2, so the y coordinate is 2. And the radius is the square root of 9, which is 3. So this circle's center is at negative 2, 2, and its radius is 3. All right, let's do one last example here. For this particular example, both the coefficient on the x and the coefficient on the y were 4, which made it kind of the two trinomials almost identical. So let's do one that has a little bit different coefficient on the x and the y. Okay, so let's put this equation that's in general form in standard form. And again, I do know it's a circle because I have the x squared and the y squared. So that would make this the equation of a circle. So I'm going to rewrite and put the two x's together. So I have x squared plus 8x. And put the two y's together, y squared minus 2y minus 8. And now I'm going to move that constant to the right-hand side of the equation. So that negative 8 is going to become positive 8 when I move it because I'm adding 8 to both sides. So add 8 to both sides. And now we're going to rewrite it with a little space after the 8x and a little space after the negative 2y equals 8. Okay, so now we're going to add the constants that will force the two terms in x and the two terms in y to be perfect square trinomials. So I take the middle coefficient, the coefficient on the x. So that's 8. I'm going to take that number 8. I'm going to divide it by 2, and I'm going to square it. 8 divided by 2 is 4. 4 times 4 is 16. So I'm going to add 16 right here. And then whatever I do, oh my, I hit the wrong button. Let's start this again. All right, so whatever I do to the left-hand side, I'm going to do to the right-hand side. Now I'm going to complete the square on the two y terms. So I have the middle term there is negative 2y. So the coefficient on the y is negative 2. And I really don't care about the sign because I'm going to square it and it's going to become positive anyway. So I take 2 over 2 squared, which is 1. 1 squared is 1. So I'm going to add 1 there, and I'm going to add 1 there. All right. So now this is a perfect square trinomial because I forced it to be a perfect square trinomial. So that is going to factor to x plus 8 over 2 is 4 squared plus y. And since the middle term is negative, this is going to be negative. Half of 2 is 1. So it's going to be 1 y minus 1 squared. And what do we have? 8 plus 16 is 24 plus 1 is 25. All right, so then what is the center of the circle? What am I subtracting from x? I'm subtracting negative 4 because it's plus 4. So since we're subtracting negative 4, the center is at negative 4. We're subtracting 1 from the y, so the center is at 1. And the radius is the square root of 25. Square root of 25 is 5. So the center of this circle is at negative 4, 1, and its radius is at 5. And that is the end of section 2.8.